Hey Flynn, how you doing? This is Matt O'Brien with SkyScene Aerial Imaging. We spoke yesterday, and I just wanted to send over this quick video for you. What I'm going to do is I'm going to just show you. I mentioned we have two different aircrafts to collect data. One's kind of visual purpose, and the second, which I'm going to be showing you today, is complete informational purpose. It creates our 3D models, our point clouds. We tie in control. You can tie that down to ground. We create 2-scale orthomosaics, and I'm going to show you a little bit about that here in this video. My contact information is on the bottom of this page here. If you have any questions, feel free to call or email me anytime, and feel free to pass this around to any of your colleagues as well. So I just want to start with the EBE. There's a picture of it. It's a very sophisticated unit. It flies off the GNSS satellites. It's an autonomous aircraft. It carries Topcon survey gear in it, has wind sensors and ground sensors, has artificial intelligence for birds or moving objects, trees, things like that. We program a flight and it flies itself. We just launched the unit by hand. It takes off, flies the mission, and lands itself. So it's a pretty awesome unit here. So let's hop into it. I'm going to start here with Google Earth. This was just a project we did last week for one of our clients, San Diego River Conservancy. They're just building a trail from the bottom. This is El Monte, over by El Monte Park and Lake Jennings. So if you're familiar with that, it's kind of East County out by Lakeside. And what they're doing is they're building a 2.5-mile trail that switchbacks up this mountain, connects into this old trail, and they're going to repave and kind of rebuild this trail to come back and loop in to the trail of their campground. So all we do with our customers is we have them go on Google Earth. You're just looking at Google Earth, nothing special here. They go into Google Earth and they just draw us a polygon around what they want flown. So in this case, they drew us this polygon. This is the area of interest that we need covered. They email it to us, a very small file, and then we take that and we put it into our ground station software. This is our software in which we control our aircraft from. So we have all of our monitoring and instrument boards on the right hand side here, which I can go into much more in depth with you at another time. I just want to show you how we collect the data and what we do with that data. We fly in a corn row pattern, so it just kind of flies back and forth, taking tons of photos. This is a small project, about an 86-acre project, and we got about 260 photos, just a little more than 260 photos off this project. We take all of those photos and we run it through our post-processing software. We tie in control if there is ground control, and that's how we end up with our models, which I'll show you here in just a minute. This unit does fly with the elevation of the Earth, so we bring in we'll bring in the Google Earth elevation data so that our bird stays the desired height. In this case, we flew at 324 feet off the ground because by doing that, we create the pixel resolution of each pixel in our orthomosaic image because it's a 2-scaled model or a 2-scaled photo, which goes right into CAD. Our engineers and our surveyors do 80% of their line work off of because it's a straight down image, which I'll show you in just a second. So moving on, I'm just going to be going through this kind of quick and fast just to kind of show you, again, some samples of different things here. So this is the model that it created. Up above you have all of the photos that were taken, and then the point cloud, the 3D point cloud of the area of interest for the customer that was flown. In this case, like I said, it was this pipeline here and this side of the hill. So what I do here is I'll put on these rays, the camera rays. Every time I click, you'll see the camera rays update, and it will show you all the photos that are associated with that point in the point cloud, as well as it will show you on the side here. These are all the photos associated with that exact point. So we have 25 photos associated with this exact point from all different angles flown from above ground from the unit. So here's all the photos here. Every time I click, they update in real time, so you can see everything. We'll show you in the image too that it creates how good the zoom capability is on this image. So if I remove those, we come in here. This is a point cloud. This is a densified point cloud. But if I come in here, here's all your points. They hold an RGB value. So when I zoom out, it's kind of picturesque looking. It gives you your 3D image. It just has color values to it. So every time I click on a point, that's a point associated in the point cloud with a long, lat, and elevation. So in this case, we do generate intensive reports, QA/QC reports for every project that we do as well, which I can show you another time. But at the bottom of this report, we have just over 40 million, like a little bit over 40 million points. So for example, that would be your land surveyor walking and shooting 40 million points, just to give you an idea of, you know, the ground and the amount of points that we gather to create these point clouds. This is used multiple different ways. We have customers environmentalists that do, they create surfaces, they do watershed analysis. We work with Granite Construction, Rick Engineering. We do photogrammetry work with it. They do planning off of our orthos. They use the point clouds to create surface models. They do volumetric readings with it, feasibility analysis. It's endless really, because all of this stuff that I'm showing you that we generate it exports in multiple different ways. So it can go into CAD, Carlson. We can take it into DXF files, LAS files, LAZ files. It exports multiple different ways to be used. But I'm going to keep moving on, and I'll just show you. I'm going to show you our TIFF image here. So here's our TIFF image of the same site that you just saw. And what I was talking about, you can see if I zoom in here, the zoom quality is very good. Environmentalists, they like it to count trees. We have multiple different things that they use it for. But if I zoom in to the pixel level, this is the ground sampling resolution or distance that I was talking about. So when we have our aircraft fly at a certain elevation, it creates a ground sampling distance, which is calculated in the pixel form. That's how it creates our point cloud, and then from our point cloud, this image is derived. So it's a mapping grade image. Each of these pixels will be the ground sampling distance of the point cloud, which is in this report. So in this case, it was 1.2 inches was the average ground sampling distance for this project. So each of those pixels are 1.2 inches, because if you take this into CAD, you can do measurements off of it. We have a construction company that they go up into canyons and they put conveyor belts way back into canyons. They use this image to measure all of their conveyor belts, the length of the canyons. It's really kind of endless what they can do with this, and you can see the quality. It's a very good image. It's straight down from everywhere you look. It's not like traditional photogrammetry where it's skewed or tilted to get the stereo view. This is a straight down image in every aspect. So that's why they're able to put this into CAD and do a lot of line work just off of this image alone. So kind of moving on here. We can create surface models. We work with an engineer, a real close engineer here. For example, this customer wanted to know how much material was in this bank on one of the sites we flew. We gave them the existing and the proposed surface, things like that. We do elevation models, so you get your DSMs. This is just a quick, brief view of that. We can put these in shape files or CAD files as well. These also, you can create contour lines. It's all contour mapping. This is just right out of our system in a PDF format of our contour lines and our TIFF overlaid under that. So we do multiple different things. We can make Google KML files, and we can upload that file right into Google Earth and give you the updated image right on Google Earth, geo-referenced, geolocated, a lot of different things. I'm not going to keep you too long here, but if you have any questions, we'd love to give your company, your department, or any of your colleagues a demonstration or a WebEx demo or a live demonstration with a flight. So if you have any questions, please reach out to me, Flynn. My contact information is on the front. Have a great day.